A small business owner budgets $2,200 to purchase candles. The owner must purchase a minimum of 200 candles to maintain the discounted pricing. If the owner pays $4.90 per candle to purchase small candles and $11.60 per candle to purchase large candles, so what is the maximum number of large candles the owners can purchase to stay within the budget and maintain the discounted pricing? So first we have to assign some variables for the number of small candles and number of large candles. Let me do it. Okay, I assume S as number of small candles and L as number of large candles. So according to the question, I have to find the maximum value of L, and L has to be an integer, I mean the whole number. So because L refers to number of large candles, the number of candles cannot be a decimal. Okay, so now let's use the first information. So the first information says the owner must purchase a minimum of 200 candles. So that is when I add the number of small candles and number of large candles. So it must be minimum 200. That is S positive L must be can be equal to 200, or it has to be greater than 200, because the minimum number of candles must be 200. So S positive L must be greater than or equal to 200. Okay, let's say, okay, now let's use the other information. If the owner pays $4.90 per candle, that is for one candle, one small candle, is paying $4.90. Then how much does he have to pay S number of small candles? We have to multiply the cost of one small candle, $4.90, by the number of small candles S. So I'm getting 4.9 S. So this is the amount he pays for S number of small candles. And the price of one large candle is $11.60. Then how much does he have to pay L number of large candles? We have to multiply the number of large candles and the cost of one large candle. Then I'm getting 11.6 L. When I add them, I'm getting the total amount he has to pay for S number of small candles and L number of large candles. So his budget is just $2,200. So it cannot go more than $2,000. So the total money he spends for purchasing candles can be $2,200, or it has to be less than $2,200. So we can write this one as less than or equal to $2,200. Okay, now we have a system of two linear inequalities. Okay, so in this system, we have to find the maximum value of this L, and also it has to be a whole number. Okay, usually whenever we have a system of two linear inequalities, the minimum or maximum value of either the first variable or the second variable always will occur at the point of intersection of the two lines. So here, they ask us to find the maximum number of large candles. That means they ask us to find the maximum value of L. So the maximum value of L will occur at the point of intersection of the two lines. So there is no minimum value, because either will have a minimum value or maximum value for each variable when we have a system of two linear inequalities. We cannot have both minimum and maximum value for any variable. Anyway, so what we can do is we can write each inequality as an equation. So if I write this first inequality as equation, I'm getting S positive L is equal to 200. And so the second, if I write the second inequality as an equation, I'm getting 4.9 S positive 11.6 L is equal to 2,200. I name this is equation number 1 and this is equation number 2. Okay, now so to find the point of intersection, at the point of intersection I have to find the value of L. So for that I have to solve these two equations. At the point of intersection only we'll have the maximum value for L. So because in this case we'll have only maximum value for L, because the question says maximum number of large candles, will not have minimum value for L. Okay, so to solve this equation, what I'm going to do is I'm going to take the second equation as it is, and I multiply the first equation by negative 4.9. Why? So because already we have 4.9 s over here. When I multiply the first equation by negative 4.9, so it will become negative 4.9 s, and I'll be able to eliminate the variable s, and I can solve for L, because our aim is to find the value of L, which refers to number of large candles. That is, we have to find the maximum number of large candles. Okay, now let me write the second equation as it is. That is 4.9 s positive 11.6 L is equal to 2,200. Now I'm going to multiply the first equation by negative 4.9. So when I do so, I'll be getting negative 4.9 s, and negative 4.9 times L will be negative 4.9 L is equal to negative 4.9 200 will be negative 980. Okay, so now we have to simplify this one. Here, positive 4.9s, negative 4.9s will cancel out. So when I simplify this one, I'm getting 6.7L. So when I simplify this one, I'm getting 1220. So now to solve for L, I have to divide both sides by 6.7. So the 6.7, 6.7 will cancel out. L is equal to, when I divide 1220 by 6.7, I'm getting 182.089. It keeps going. Okay, so I got the value of L. I mean, so the value what I got now for L is the maximum value of L. That means L can be equal to this value, or it has to be less than this value. That is 182.089, and it keeps going. So this is the maximum value of L. But the L, the L refers to number of large candles, so L cannot be a decimal. So what do we have to do? So L has to be a whole number. So we cannot round this one to the next whole number because the maximum value is of 182.089. So otherwise, the value of L can be less than this one. So since L must be a whole number, this decimal number has to be rounded down to the nearest whole number. In that case, I am getting L is equal to 182. So this is the maximum value of L. So that means the maximum number of large candles the owner can purchase is 182.